Hello students. So we will write a program to find smallest number in n number of 8-bit binary numbers. So you can write your program in your new file. By clicking on new file, you can write program here. And after that you can save it, load and run your program. So I have already written this file. I am just opening from here, and you can see here is it, smallest number. You must be clear about algorithm we are using in this particular program. So how can we find the smallest number from n group of 8-bit binary numbers? It is very clear. First of all, we need count of numbers, how many numbers are there, and our objective is to find the smallest number in that count. So we can approach this program by putting one number in the accumulator and comparing other number from memory to the number in accumulator, and you can see there must be a carry or not, or no carry. Like if comparison is there, either carry flag will be set or it will be in reset position. Okay, it will not be set, it will be 0. And other one is we must have to take account of the count register. We need to decrement it once we got our smallest number by comparison, and once the count is 0, that means now we do not need any loop operation and we have sorted out our objective, which is to find out smallest number. So basically two loops are there. One is controlled by decrementing the count, and other one is conditioned by your carry flag. So let us see your first instruction, LXI D 3500. This is immediate instruction to load D register pair with memory location 3500. This instruction is used to store data. So this is our result data here in this 3500 according to stacks D at line number 20. Okay, stacks D store accumulated in D register pair. So D register pair we have allocated 3500 memory location. So accumulator content in the end of the program will be stored in the D register pair. So we have allocated this memory location 3500 to D register pair for our result, that is the smallest number. So next instruction, we have immediately moved count of numbers, how many numbers are there. So in this case I have taken a count of 5, means we need to find smallest number in given 5 numbers. Next instruction is again a immediate load in the instruction for HL pair with memory location 3000, and this is a 3 byte instruction. Next instruction is move AM, which is a single byte instruction, and according to this instruction data from memory is moved to accumulator. And next instruction INX H HL pair register memory location is increased by 1, that is 3001. Next number is stored in this memory location 3001. And now compare memory number to the accumulator by instruction CMP M. Your one number is in accumulator and other we got from memory, that is 3001. Both are compared, and after comparison there will be two conditions in flag register. Either our flag register will be set if the content of the accumulators are smaller than memory content, and otherwise it will be reset condition, 0 condition, if the memory number is smaller than accumulator number. So next instruction, if carry occurs, then we need to jump to program address 200F, which is our decrement DCRB instruction, line number 17. Okay, we will directly jump to this, and after that we will monitor the status of the register B. If our register B is 0, then we will move to the next instruction stacks D at line number 20. We will store the accumulator number in the D register pair at 3500, and we will get our smallest number. Otherwise, if this is not the case, count is not 0, then we will jump back to the program address 2009, that is INX H. We will again increment the HL pair by 1, means next number will be there in the memory. Again we will compare that number with the number in accumulator. In accumulator, just look on line number 15. If there is no carry, then we will move the number which was previously in the memory to accumulator. The number which was a greater number than accumulator, we will move it to accumulator. After that, count will be decreased. You must be aware carry flag will be only set if the number in accumulator is smaller. Only that we need a carry. Only in that condition carry flag will be set. If carry flag is set, it means we have the smaller number, and we move directly jump to 200F. That is decrement B, line number 17. And after that we will monitor the count register B. If contents are 0, if count is 0, then we got the result. Otherwise we will, if not 0, we will go back to the loop operation from program address 209. So this is our complete program. We can just load it. This is our starting program address, and you can see the program counter position 2000. It is showing the program address of the next instruction to be executed, and stack pointer always point to the top of the stack. So one by one we can see the complete program, and here we can see our count B is decrementing one by one. Now the count register B is 0. The execution is finished. 0 flag is set, parity flag is set. Okay, 0 in accumulator and even parity, even number of ones, 0, 2, 4, 6. For those, our parity flag is also set. So we can just load our numbers at 3000. First we need to put program address. After that, examine the memory location. It is 3000, starting from 3000. You can put a number. Next 17, next 14, next 0 A, next 08. These are our numbers, and our program will find out the smallest number at memory location 3500. The result will be stored in D register, whose memory address is location and memory location is 3500, right? Just execute. We need to go to the program address first. So program is executed. We can examine our memory locations. Six, 17, 14, 0, 0. So examine okay. Okay, I have changed the number, that's why it is showing this. So once again we need to change the number. 3000, 6, 17, 14, 0 A. and here I can put 05, right? Now examine 35 05, execute, go 2000, execute. So now examine 35 okay 2000, go 3006, next 435, go 2000, examine 35, jet. Okay at 3500 would be our smallest number, but here it is nothing there. So okay, it will not stop now because we have started the program without feeding our count. That is it. Cancel, cancel, clear rock. Okay, okay. So now I need to just switch off my phone. Only that is the way. It will all the memory locations.